Okay. So once again, welcome everyone, and this is our virtual meetup number 7. And today's topic will be effective unit testing in MuleSoft. And we have our special speaker Josh. And to introduce, let me just navigate through the slides. So I am Ikram, and I'm a integration associate at one of the insurance company located in Indianapolis, and I'm a MuleSoft meetup leader and a mentor as well, and I have 15 plus years of IT experience. And I'm also certified MuleSoft integration developer and a platform architect. And that's about me. Uh, I'll go ahead and give control to Josh. So Josh, you can take the control. I'll stop sharing, and you can start from there.
All right. There we go. Cool. So I'm going to try to pick the right screen here. Let's see. Do this one. Okay, you can see my Anypoint Studio. We have the PowerPoint slides. Actually, I don't. When I'm going through the presentation, feel free to stop me at any time and ask any questions. Ikram, I don't have view of the actual chat right now, so feel free to speak up if somebody.
I'll monitor the questions. And do you want me to stop you in between, or you want me?
You can stop me whenever.
Okay, and you can let them know about the trivia questions as well. That when do you cover the trivia questions?
Yep, I will let y'all know.
Okay.
So yeah, feel free to stop me anytime. Okay, wait. So this is me.
Josh,
a younger.
Sorry to interrupt. Manik is asking you to increase your resolution on Studio, if you're trying to show something on the Studio.
Yeah, give me a sec here. Let's see if I can. I don't even know if I've done it before. Let me see if I can. Is it properties or preferences?
Even I have not done, so I'm not sure.
Oh, I have an idea. Yeah, Mac. Okay. Yep. Okay. I don't know why that didn't
Monica is just checking whether you know everything, right?
Yeah.
Just
Put me in the hot seat.
Yeah.
Let's see. Displays. Yeah. Okay. We want to go to default here. All right. So this should be considerably larger. Let's bring up the palette and just see how that looks. Okay. How's that look? It's much bigger. Okay.
Yeah, it's better.
Thanks for letting me know, because we've gone through whole presentations where the screen size has been small and nobody can see it. All right. Let me hide that real quick. Okay. One more time. Okay, so this is me, a younger version of me. My name is Joshua Ernie. I go by Josh, and currently a MuleSoft ambassador. I've been developing and architecting MuleSoft solutions for, I think, about 5 years now. I haven't counted in a while. My kind of high level approach to software development is from a financial and long-term maintainability standpoint. I'm trying to reduce costs of the overall enterprise or increase value. And one of the easier ways to do that, besides building effective architectures, is making sure that your code is maintainable long term. I typically go by the saying, if you want to go fast, do it right. This is something I learned a while ago from a colleague of mine when we were working on a project. He was we were trying to move fast, and I was trying to move fast, and he kind of slammed the brakes on me real quick. He had about like 20 to 30 years more experience on me. And he slammed the brakes on me, and he wanted to build all of this tooling around the project. So he was basically building these Docker Compose files that would set up our development environment. He had a bunch of bash scripts that could interact with those tools and speed up things for us. I didn't really see the value in it at first, and I felt that we were moving really slowly. But once everything that he wanted to build was built, and we had all of that tooling and better understanding of the project, we were actually able to go much faster on average than if he had just gone with what I was doing and just started like running into things, getting requirements, so on and so forth. So I kind of took the lesson there, and I've been applying it ever since. I don't like to rush through things when it comes to IT development, because that's a really easy way to just create a lot of tech debt along with your solution. So I'm always trying to do things the quote unquote right way. And today I'm going to be talking about the right way I feel that there is to write unit tests for MuleSoft applications. A little bit more about me. These are my two dogs. They're both little Pomeranians. The one on the left is Eddie, and the one on the right is Benny. I wrote a tutorial for the DataWeave Playground. I write a lot about DataWeave. You're probably wondering why I'm talking about MUnit right now in this presentation instead of DataWeave. It's just equally important. And I also wrote half of a DataWeave book once, so reach out if you'd like the link for that. So let's get into it. So I think there's 5 main steps when it comes to writing effective unit tests in MuleSoft applications. And the first one being the most important: understand the value of unit tests. We want to assert our code meets interface contracts. We need to be writing code that's actually testable. It's fairly easy to write code that is very difficult to test, but it's also easy to write code that's not difficult to test. So we're going to kind of distinguish the difference between the two. We want to remove the noise. We'll talk about what noise is when we get to that part of the presentation. And we want to make sure when we're doing things in terms of prioritizing how we're writing our tests, that we want to prioritize writing all of our valuable tests first. And then we want to worry about code coverage as kind of a secondary target. And we'll discuss exactly what makes a test valuable in that section as well. So where did these steps come from? Over the last year, and this was like maybe 6 months ago, a year before that, I was doing a lot of code reviews. I was doing a little bit of developing, creating a lot of tooling to make our processes more efficient. And most of my time was spent doing a lot of code reviews, and a lot of code reviews on like the same type of project. And I found a lot of things that were kind of holding us back when I was doing those code reviews. There were 10 to 15 developers. So I was looking at code from a lot of different perspectives, I guess. So we were getting good overall increases in code quality. Like the tools that I was developing were resulting in applications that were written more in compliance with the kind of standards that we had, but the tests were still lacking. And I kind of figured out that, okay, well, just because developers know how to maintain source code and write maintainable source code doesn't necessarily mean that they know how to write good tests. The skill of writing a good unit test is not the same skills that you need to write good tests. I mean, a good source code, but they do tend to, there are some definite, what's the word I'm looking for? There's definitely some similarities between the two. So developers were writing unit tests because they were required to, but the tests were weak. I see this all the time, where management, or your Scrum Master, project manager, any of those people are saying, hey, we need unit tests, but they don't really understand why we do unit tests. What's the value of creating unit tests? Can you create bad ones? Can you create good ones? What kind of damage do the bad ones do to your speed, development speed, so on and so forth. So they were all creating these tests, and we had these tests, but they weren't really testing anything important, I guess. So code was passing we had automated build and deploy processes. We had CI/CD. We had all these nice little bells and whistles. But But when we sent the code to QA, there were still bugs in it that should have been caught by unit tests. Code coverage was high, but test quality was really bad. Unfortunately, just because your code coverage is high unfortunately doesn't mean anything else. It just means that your code coverage is high. It doesn't mean that your tests are good. After speaking with developers, I learned that most of them just didn't understand why we were writing unit tests. So imagine imagine you're trying to fire a bow and arrow down a range and then someone throws a blindfold on you. Like, what are the chances that you hit that target unless you practice firing bow and arrows with the blindfold on? So they didn't really know how to create valuable tests. And that was something that we kind of needed to teach everyone over time. And that's one of the reasons I put this presentation together. I wanted to kind of spread this information outside of the team as well and into the greater MuleSoft community. So the big lesson here, ultimately, just having unit tests isn't enough. Having poorly designed unit tests can rob us of productivity and increase maintenance costs. And I hate to say it, but it's actually better to not have unit tests than it is to have a bunch of bad ones. And I know that might sound shocking because, you know, management is always pushing us to create these unit tests. But if you don't know how to create unit tests, you're actually you're better off not having them at the time.
Yeah,
So talk
another
objectives.
challenge. Yeah, sorry, Josh. Another challenge that we see usually is like the timelines, the project deadlines and timelines. So they focus more on the delivery of the code and not on much testing on the minutes. So the developer
Yeah.
tends to focus more on the code, not on the unit test. So that's one thing. And they think that spending time on unit testing is not much worth when it comes to the timelines of the projects
Yeah.
sometimes.
Let me say that in those situations, it's kind of our responsibility as engineers to make sure that the time that it takes to write the unit test is factored into the time to do the original development. Usually so let me just tell you how I go about this. If somebody gives me a requirement or a Jira ticket, for example, and it's just a user story, and I look at the user story and I'm like, oh, this should be pretty easy. I should be able to get this done in about 16 hours, maybe like 2 days. I would never tell the product manager that I could get it done in 16 hours. I would say 32. Simply because, one, I could run into issues when I'm doing development, right? Maybe some unforeseen things. Maybe there's like a bug in one of the libraries that I'm using and it takes me a while to uncover it. But the main part is it's probably going to take me as long to write my unit tests as it's going to take me to write my application. And you can be forthcoming about that and say, it's going to take me this long to write the code. It's going to take me this long to write the unit tests. But I typically don't do that because that sometimes can prompt the project manager to break it into 2 tickets, right? And once it's 2 tickets, once you've separated the responsibility of unit tests from the code, I guarantee you the product managers are like, which one's valuable, which one's expendable? They're going to think the source code's valuable and the unit tests are expendable. So some techniques for dealing with that is kind of you overestimate and how long it's going to take you to do a task. If you think it's going to take you 2 days to do the code, say it's going to take 4, and don't make sure that the responsibility of the source code and the unit tests are in the same ticket.
Okay.
Yeah, thanks for pointing that out. That's actually a really big issue that I see very, very frequently. And it can be hard to deal with because deadlines are important, right? But we always have to be forward thinking. Everyone wants to solve the problem that we're experiencing at the moment. But if you solve the problem at the moment and create 5 new problems for the future, you've kind of just shot yourself in the foot.
Exactly.
So talk objectives. Once we are through with this presentation, I want you to be able to describe why we write unit tests, be able to identify high-value test cases within your code, understand how to write these high-value tests, how to write testable code and refactor non-testable code into testable code. How many times can I say testable code in this presentation? We will find out. That's not a trivia question, though. And I'll show you examples for this, concrete examples that I've seen in the wild. And And finally, we want to understand why we need to be thoughtful when using the EffectiveMunit test recorder. And I'll dive more into that when we get there. So number one, understanding the value of unit tests. So why do we create unit tests and what makes them valuable? I'm going to close the presentation real quick, and can people just start typing in the chat some of their opinions on this? And I see that share the book details. I will get the link for the book details now while you all are writing down what you think there in the chat. Okay, we only got one. I know you guys. Better to create an integration. Catch regressions, that's definitely a good one. So regressions are, if you don't know, a regression is, let's say I already have an application that I've built and I go in to create a new feature. And my new feature works beautifully, but I had to change a flow that another feature is using, and I accidentally break that flow and I deploy it. And now my shiny new perfect functionality is great, but I have broken existing functionality. When you break existing functionality, that's referred to as a regression. Any others? Okay. Get the exact error codes. That can be a good one for sure. Check how our code works in case of positive and negative scenarios. I like that one. I would boil that down to unit tests help us understand how our code behaves in certain scenarios. Make sure the code works correctly. Absolutely. Please share book details link. Will do. Verify and assert the behavior of a unit of code. It makes easy on maintenance and modify easily. Yeah, that's a really good one. The main value of unit tests, in my opinion, one of the main ones is reducing maintenance costs for the future. We create the unit test because it will automate the testing in Mule technology. We do not want to switch to other technology like Java. I'm not sure exactly. We don't have to switch. Automate the testing in Mule technology. I'm not sure I understand that one. Test things that are hard to reproduce, like exception handling. Unit testing can definitely be good for that. It gives us a chance to think about all the code paths. That's a really good one. It's often the case that we might only unit test one of the code paths. And by the way, that's not necessarily a bad thing. If you leave out certain branches of code, it just might be the case that that code isn't as valuable to test. Okay, here's the book. All right, let's get back to the presentation. Those are all good answers. I clicked this twice. Weird. All right, so this is the list I put together. Unit tests may increase code quality. So maintenance costs go down, development velocity goes up. That's the case for all of these points, so I'm not going to keep repeating that. It may enable developers to confidently refactor. That's one that I didn't see in the list. And refactoring is changing the internal structure of the code without changing how it behaves externally. So the API and everything doesn't change. If it's an adding function and I pass it 1 + 1 and 1, it's going to give me back 2 every time. I might change the way I do adding in the implementation of the function, but to the end consumer of that function, it's always the same. That's what a refactor is. It may enable developers to confidently add new features without introducing regressions. This is something that we talked about earlier when I was looking over some of the answers. It may reduce the quantity of bugs. And this is one of my favorite ones. It may serve as a form of documentation. Imagine you are looking at a piece of code in the Mule palette and you're just like, what is this? How is this supposed to work? What are the expected inputs? Given those inputs, what kind of outputs am I expecting? So on and so forth. Those are all really good questions, and they should be answered by a good unit test. So let's look at this one more time and look at some of the stuff I've kind of put in bold. You'll notice that it may increase the code quality. It may enable better refactoring, maybe getting regression, so on and so forth. It's unfortunate, but we don't get any of these things for free just because we write unit tests. Just because we have the unit test doesn't mean we get the value that they can possibly provide, right? Just because you know how to code in MuleSoft doesn't necessarily mean that you know how to add value to a company through good integrations. So tests are for future you and developers that may need to modify your code in the future. There's always going to be, if it hasn't happened to you yet, it will happen to you in your career, where you will write a bunch of code, you'll walk away from it for 3 months, and you'll come back to it and you'll just be like, what the heck is this? Like, you've never seen it before, but you were the one that wrote it. You can always go back to the tests and kind of retrace how your application is supposed to be working through those tests. Okay, so this brings up our first trivia question. What is one of the benefits of writing valuable unit tests? A, it makes your boss happy. B, it may reduce maintenance costs. C, you get better code coverage. And D, it may eliminate all bugs from your application. Please pick the best answer.
We are getting some answers.
Well, you guys are really good. Okay. maybe it was my presentation skills were lacking the last presentation I did, but it was a really mixed bag. Excuse me. Okay, I think we can. So the answer is B. It may reduce the maintenance costs of your application.
So the first person to answer is Kishore Katragada.
Awesome. Congratulations.
Congrats, Kishore.
Let me go over some of these other ones real quick. It makes your boss happy. Yeah, it is. But that's not why we're that's not why we're writing code, right? C, you get better code coverage. It's a maybe on C. You might get better code coverage, you might not. Just because a test is valuable doesn't mean it has a ton of code coverage, for example. You might only cover 5% of your application, but that 5% of your application could be the most complex logic that your application has, for example. So bad code coverage, but a really high value test. D, may eliminate all the bugs from your application. The reason this one is wrong is because it says all bugs. There's just no possible way to eliminate all the bugs from your application and have your application actually be useful. So unit tests do cover a certain set of bugs that you may encounter, or a certain subset of bugs, I guess. But when you think about it, like you have to create a very strict set of inputs and map them to a very strict set of outputs. We're not really covering the whole range of potential inputs that we might get from unit testing. That's kind of more into property-based testing and things like that, which we don't really see a lot in MuleSoft applications. So that's why D is not correct either. All right, let's keep on going here. Second section, assert code meets interface contracts. So what does this all mean? What it kind of boils down to is, given certain inputs, we'll just call them X. Are the calls to all of our dependent APIs correct? For example, let's say we take in an API call through a RAML contract, and one of the things we have to do is reach out to another system to get data from it. Maybe merge it with data from another system and then return the result. We need to assert that given the input that we got from the original API call, that the API calls that we made to downstream systems are correct given that information. So if we're pulling information out of X, we want to make sure that information we pulled out is going to system Y and system Z. If the API is synchronous, so if you have a request and response kind of API that we typically see with REST APIs, is the response body correct? Is the body good? Is the HTTP status code correct? The test should be failing if the code does not meet the interface expectations. A test that I see a lot is basically it's just a flow ref, a ton of mocks, and then at the end they assert that the payload is not null. Now, if you remember what I said earlier, given certain inputs, like very specific inputs, we want very specific outputs. Is asserting that a payload is not null asserting that it's a specific output? No. What you've basically done is say the payload can be almost any value except for 1. And we kind of want to do the opposite. We want to assert that the payload is just this one value and not the whole universe of other potential values that it could be. So anytime you see payload is not null, it's almost never enough. This is a huge code smell. If you ever see this, ask questions, get to the bottom of why it's there. You'll probably figure out that there are better assertions that you can make, and go with those instead. So tests of this type, these interface contract tests, should never be viewed as optional. Let's kind of talk about what an interface is. I think everyone is very well versed in the fact that RAML creates an interface. It's our API contract. But an interface is really just like a contract for how we deal with a particular piece of code. Flows and subflows have interfaces as well. Their interface is the mule message. So the payload, variables, attributes, etc. They don't have to be a specific payload, a specific variable, or specific attributes, but it does have to be a mule message in order for a flow to accept that as input and a subflow to accept that as input. It's our job, because of that dynamicism of allowing any payload, any variable, any attributes, we need to make sure that our tests are narrowing that kind of the possibilities of what that interface will allow. So we want to make sure that flows and subflows that they are past certain variables or past certain payloads given other information. You can also look at HTTP requesters. You can say that they're an interface as well. Any processor you could say has an interface, but the question is like, how granular do you want to get your testing? You don't want to have to assert that everything going into the logger is expected, right? That's not really a good use of your time. And I'll kind of show you an example here next that'll show you how you can kind of strike the balance between, well, what interfaces do I test? Do I test the API interface and that's it? Do I test these flow interfaces? Do I test like loggers and things like that? Probably not, but we'll get into it. Okay, so let me go into my first example here. Oops, what happened? Just went down one. Okay. So the first thing I'd like to show is the code. So we have this HTTP listener here. It's just listening on on activities. And what it does is it goes out to this API. This is called boardapi.com. And what boardapi.com does is you send it a query parameter of a certain, you basically say type. It could be education, it could be social, it could be relaxation. And what the API turns around and gives you back is this is a JSON object that gives you like a random idea of what you could do if you're bored. Okay, I promise I didn't plan this. Start a webinar on the topic of your choice. So it's totally random though. I promise. It's totally random. Let me do another one. Okay, there we go. Learn more. Still code. Okay. Anyway, so you can and you could switch this. I think you can switch it to things like social for the type, and it'll give you something different. It might be like hang out with friends or grab a drink or something. Play a game of tennis with a friend. So you can get different activities from this. The whole purpose of this flow is I'm bored. I want a suggestion for 2 types of activities. want a educational activity and a social activity. And that's just the same call, it's just using a different query parameter there. So we'll see down here. Type social. I just logged the payloads here. This is for debugging purposes. I should say you shouldn't log payload on info most of the time. This is just for me. And this is a small little example. We're gonna merge these two payloads together, output them as application XML, and we're gonna return that back to the user. So let me go ahead and run this project real quick. Probably should have booted that before I started talking, but that's okay. And what I'm gonna do is I'm gonna hit this endpoint and we're gonna see what it does. And then finally, once we all understand how the application is supposed to work, we're gonna talk about the test that I have in inserting code. Ooh, that's not good. It might have been already running. Let me see here. Let me check something. Is it activity something? Activity monitor. I have a rogue Java process. I'm actually just going to try to boot this one more time while I'm looking at this. Here's a Java process. Okay. I quit out of Anypoint Studio here. I'm going to, okay, those Java processes went away. I'm going to launch this one more time. If it doesn't launch, there's that off chance that it just won't work. Not a big deal. We can just go through the code. It's actually not that important what the output is in the grand scheme of things. I already have it documented for the tests and whatnot, so we can just look at it there. But it would be nice for it to run, wouldn't it? All right. We're going to give it one more chance. Okay, saw that earlier. Moment of truth. Wow. All right. Well, I hate to say it, but I've done this presentation 3 times, and every time it has failed in a very different way. Which is really unfortunate. Okay, so let's look at the unit test here real quick. The unit test I have here, I'm mocking those 2 HTTP calls, and I'm defining what they should be giving me back in return. So the payload is just on the class path. I really like to organize my, I call them test fixtures. This is basically just, these are like payloads that I might get, are just like large pieces of data that I don't feel like writing inline in the actual unit test. So I go into test fixtures, I have a folder with the name of my test suite, and then I have a folder for every one of the tests that I have in this particular project. So I have my get educational activity response. This should look very familiar. It should look exactly like the what I received from the API here, right? I have my social one, and then my response payload.xml. This is what I was going to show you if the application started and returned. It would give us back something like this, and that's what we'd expect to get. And notice that the assertion is extremely specific. Given that I get these two things back from the mock, my payload should be exactly this, whatever I have here. The other thing I want you to notice is that this isn't DWL. Like, this isn't a data weave representation of this particular output. It is instead it's just the raw XML. And this is the raw JSON. It's not some kind of DW object or anything like that. The reason, and I think it's important that you do that, the reason being is because I can take these pieces of raw data, plug them into other tooling like Postman, and it just works. I don't have to go through the MuleSoft playground and insert this data and output it as application XML and copy that and put it into Postman, so on and so forth. It's all there, ready to go. If a developer wants to use this for something else, all they got to do is copy it, paste it, and they're good to go. They don't have to do any kind of transformation. So let's talk about the interfaces real quick. There's two obvious ones here. You have this interface here where things are coming into the actual flow itself. We're not going to worry too much about that. This would normally be like a RAML API contract to go through the API router and all that kind of stuff. You might have some tests testing that specifically, that given this, it gets routed here and gives us the correct response. But mostly what we're interested in with this test is that, okay, given that I got back the correct information from these requesters, that the payload was transformed correctly and gave me the correct response. So that's really what I'm looking at here. Here's the input I'm asserting, and the inputs are also defined here as well, even though it's not as clear because they're mocks. And here's my expected result. So writing testable code. What makes code testable? So testable is a spectrum. It's not like you can look at some code and be like, yeah, that's testable, that's not testable, testable, not testable, so on and so forth. It's not binary. It is this kind of spectrum. But you can get a sense of whether or not your code is testable. For example, if you're dealing with a flow and you have to mock 10 different components just to assert that the output is correct or that something else is correct, you probably don't have a testable flow. That flow probably has a bit too much responsibility. You might want to break it out into multiple flows, multiple subflows, so on and so forth. So testable code is typically modularized really well. It's broken up across projects. It's broken up across whatever kind of organizational tools you have. In Java, it's classes, and data weave, it's functions. And in MuleSoft, it's flows and subflows. So code that is, and like I'm just saying, code that is thoughtfully organized into flows and subflows. You want to bias towards code organization that reflects how you would communicate about the code with other developers. This statement here, this flow gets data from system X, it collects associated data from system Y, then groups the data and sends it to a queue. Just speaking about the commas themselves almost delineate where your flow boundaries are. The flow gets data from system X. That could just be the source of the flow. Collects data associated from system Y. That would probably be a subflow. I just do a flow reference to it from the first flow. And then groups the data and sends it to a queue. I might put the transformation logic right there in line. So this actually might just be two flows. It really just depends. You probably don't want a bunch of flows that only have two components in them. But I try to make sure that my flows have anywhere like no more than like 7 to 8 components in them. And I probably average somewhere around 5, not including loggers. So this one's really important. Values that need to be tested must be visible for testing. So let's go back to our code real quick and see what I mean by that. There's one interface that I didn't really talk about, and maybe one interface that you don't really think of as an interface. Now, let me show you something real quick. If I come into here, and I go into query parameters. And I go into query parameters. There we go. And I delete this. And I change it to null. Is my test going to pass? Yes, no, maybe? What do you think? All right. No? Yes? No? Yes? No? Okay. Closet routing error. All right. Check it out. I bet you this will work. Yeah, you got it right. It's going to pass because it's mocked. Okay, let me ask you all another question. My test is going to pass. Did I break my application? Will my application still work if I run it? Oh, sorry. Did I break my application? Yes, I did break my application. Sorry, I asked the question twice and inverted the meaning of it. So yes, it will break. There we go. So note that we're in this situation right now where I've broken the core function of my application. It's no longer going to get educational activity. I'm not sure if the API will actually return to me some kind of error. It might just fail silently and or give me back like some kind of mock object or something like that. This was successful. The test passed, but I broke my functionality. So something's wrong here, right? This test is not as effective and as strong as I wanted it to be. The reason being is because I have an interface contract for both of these things. Getting educational activity expects that I send it a query parameter that has type education. And this thing expects that I send it a query parameter of type social. Now, how do I assert something like that, right? Like I can't just go into this request and there's no munit processor that gets me into this request and says, oh yeah, I want to make sure these query parameters are this value before you go ahead and execute the test. There's no way to do that with the way that the code is organized now, which is a problem, right? Because we just saw I can break the whole application, but my test still pass. We don't want that. If I'm breaking the application, my test should be failing along with it. So how do we get there? And let me show you. So look at what I did here. I pulled out query params into their own variables. Oh yeah, see, has a Belaslav. I think he's seen this presentation before. So you pull them out into variables essentially. Now I can actually do some meaningful assertions about the data that I'm passing into the requester before I actually make the request. So I set up these query params as type social, right? And in the request processor, I just go ahead and reference those variables, query params. And you could do this with anything. You could do it with headers. You could do it with the body. It's up to you. It's not always going to be worthwhile to pull everything out of the HTTP request, put it into variables, and then send those variables into the request. But in this case where it's clearly breaking, like I wouldn't pull out path into a variable unless this was some kind of dynamic value that would change depending on input. This is hard coded, and I know these are hard coded too, but you kind of have to make that. You have to decide on that trade-off. Is it worth it to bring in these extra components just so that you can test it? In this case, I'd argue that yes, it is. So currently, our test doesn't have any kind of assertions for those variables. Does anybody know what kind of processor I would use to make those assertions? And I'll kind of give you a hint. I need to test that query params are set correctly before I do the request. And there's a perfect tool in EffectiveMunit in most testing. Yeah, SPY, exactly. So let's see what that looks like. So with spies, if you recall, you can make assertions before and after a processor executes, which is great. It's exactly what we need in this case. I know I'm asking a lot of questions and they're not all trivia questions, but there are some. We got 2 more left. Yeah, I'll definitely elaborate on this a bit more. So we're going to look at. Should refresh here. Let's blow this up. So notice I still have my mocks because I don't actually want to go out and call those that API for my unit tests. I want to make sure my unit tests are completely isolated from the file system, from the network, from any kind of databases or anything like that. I don't want to get them involved. And I just say, hey, before I get this educational activity, I want to just go ahead and assert that my query param is type education, and that my spy for get social activity is the same thing. But in this case, instead of education, I want to make sure it's type social. So this gave me, this small refactoring gave me the ability to make sure that these 2 endpoints are called correctly. Chala, does that give you a little more insight into why we do that and how we do that? Okay. And there's one other thing that we need to look out for. I'm not going to blow this up because I'm only going to talk about this. Testable code is deterministic. Now, deterministic code is code that if you give it the same inputs, you always get the same outputs. So most math functions are like this, like addition. If you give it 1 and 1, it's going to give you back 2 for all of eternity. But DataWeave and MuleSoft and Java, et cetera, they do give you a lot of functions that are non-deterministic. These are functions like now. If I call now right now, I'll get a certain value. And if I call it now, I get a different value. It's the same input, which is no inputs. I just call it, but I'm getting back different values every time. Random is the same thing. You call it and you get back a different value every time. There's nothing that you can pass these functions where you get back the same value every time. So we say that these functions, these scripts, etc., any script that has these functions in it is non-deterministic. And we often now is a really important function. We use it all the time. So how do we set up our source code where we can make this test, we can make this kind of stuff testable? Round Robin does that as well, yeah. So let me check this out. So I added a flow here, really simple flow. I called date time and but look at my payload. It's just going to give me back the current date time, right, in UTC. So I call the function now here, and it just says the current date time is blah, blah, blah. I go over to my munit test. I call the flow, and I'm saying that the payload is expected. I am using another file, so we'll need to go into that real quick. I need to refresh this. So response.payload. So what I did when I made this test is I ran the code, I got the output, and I copy pasted it into this file a few months ago. So obviously this isn't going to work, right? Now is not October 6th. It's December 18th, and this time is clearly not correct either. So the way that we get around this issue is actually very similar to the way, here, one sec. We'll run that in the background. The way we get around this issue is very similar to the way we got around the issue when it came to testing the HTTP request interfaces. And that is, what we end up doing is we take this transformer, we extract now, and we put it into a variable, and then we just reference that variable in the set payload. The reason that works is because now we can mock the set variable processor and say, hey, give me the same value every single time I call you. Notice that this test failed. It actually failed for a different reason other than no such file or directory. and EffectiveMunit presentation, no artifact.json. That's not even there. In any case, we're going to, let's look at the code that would actually pass. So we come back here. Now we've extracted now into its own variable. You can do this with random as well. You can do this with any kind of non-deterministic code. The whole point here is that you isolate the non-deterministic code into some kind of processor that you can mock. I mean, it could be a transform message, it could be a variable, but you need to separate it out from the code that holds the rest of your logic. So now that this is separated out into a variable, we can go ahead and mock it. And that value that I had that was back in October, I just hard-coded, right? And I just hard-coded right here. So now every time that variable gets called, I get the same value back. So those are two kind of gotchas when it comes to unit testing and making code testable. Is one, that values that need to be tested. So these might be values that are conforming to interface contracts, like if I'm calling an API that somebody else owns, or maybe your own team owns it, but that API has a certain contract, and given inputs, you have certain outputs that go to that particular call. You need to make sure that those values are visible for testing. And when we have non-deterministic code, we need to make sure that we segregate the non-deterministic code from the deterministic code so that we can mock the deterministic code to make sure it returns the same value every single time. That way, when we call our EffectiveMunit test to run, we actually get consistent results. It's not just going to pass one time and then fail every time after that. All right, second trivia question. What is a good indicator of testable software? We have A, good naming conventions. B, the software already has a lot of tests. C, the software tests provide great code coverage. And D, non-deterministic values are extracted into mockable variables. There's multiple answers for this one, so I'll take the first correct one. Actually, there's only one good answer, I'm sorry. The answer is D. Non-deterministic values are extracted into mockable variables. A is also a good answer. It doesn't necessarily mean the software is testable, though. I mean, we can give everything all the good names that we want, but if everything is in a single flow and we have to mock 10 things just to test the output of it, it doesn't matter how well it conforms to our naming conventions. It's still not testable. Software that already has a lot of tests, it still doesn't really mean it's testable. It's likely that it's testable. If it has a lot of tests, it's probably just it might mean that the code is broken up into small flows, and that's why we have a lot of tests, but not necessarily. The software tests provide great code coverage. Same situation as A. I can have it all in a single flow. I get 100% code coverage, but my software is not very testable. If I'm requiring my developer to create 10 mocks just to test the output, that's not testable software. It's just not. D, non-deterministic values are extracted into mockable variables. That's when you know that that's when you know the developer was they were on to something in terms of writing testable software. So I think that was Rahul. Oh no,
Venkatesh
yeah.
Mahadevan. Yeah. Venkatesh, can you just ping me your email ID?
Yeah, so initially I was thinking A and D, but D is definitely the best answer there. All right. We already went through the example here. All right, 4, eliminate the noise. So now we're going to get into more talk about what noise is. We're going to try to use the EffectiveMunit test reporter. If not, I do have a Git tag that's already there for the output of it, so we can look at that, and I can just kind of talk through what's going on. But my Anypoint Studio is acting a bit wonky today. I'm not quite sure what's going on. Of course, it worked fine last night. It's not working now during the presentation when it matters. Okay, so eliminate the noise. What is noise? Noise is code or a test that cannot be linked back to a requirement or interface contract. That's just a real fancy way of saying that it's anything that doesn't matter, right? If I add a variable and it never gets used, that's noise. If I have a bunch of files that never get used, that's noise. Noise is, it's bad. Tests that don't assert anything useful. So for example, the whole payload is not null when it's just noise. I don't get any valuable information from a test asserting that the payload that it returns is not null, and neither do you. In fact, you end up with more questions. You're like, okay, well, it's not null. Well, can it be a number? Can it be a string? Does it need to be some kind of JSON object? So on and so forth. You end up with a lot more questions, and every single one of those questions that you have to ask creates doubt, and that doubt creates confusion, and it slows you down. Every time you doubt what's going on, you have to slow down. You have to ask a bunch of questions. You might have to ask questions of developers that are no longer at the organization anymore. It really, really bogs you down. So it's extremely important that when you're creating code and you're writing tests, that there is the absolute minimum amount of noise possible. And you can get it to just about zero. Like I was kind of alluding to, noise ends up increasing the maintenance costs instead of decreasing them. It just creates confusion. Why is this test making assertion about data if they're not used by the flow? Like let's say it's not even an assertion. Let's say we're setting up all the behavior for our test, and right before we call the flow reference to kind of trigger the logic that we're gonna assert on afterwards, we set like 4 headers that don't get used by that flow at all, and 2 variables that don't get used by the flow at all. I'm gonna look at that test 2 months down the road and being like, well, is the test incorrect or is the code incorrect? Is the code supposed to be accounting for these variables and using them somehow? Or did the tester just add them at some point when he or she was developing and forgot to remove them? Again, confusion, it's slowing me down. I have to ask questions, things aren't clear. I'm moving much more slowly now. And finally, the EffectiveMunit test recorder can create a lot of noise. So you really gotta be thoughtful when you're using it. So let's kind of look at the bad things that can happen when you use the EffectiveMunit test recorder. The EffectiveMunit test recorder can seem like an attractive tool because you might argue that it does a lot of the heavy lifting for you, but you have to keep in mind that writing unit tests is a critical thinking problem, right? And computers aren't good at critical thinking like humans are. So when we try to take a human task that is well suited for humans, provided that they want to put the effort into actually thinking and solving the problem, and we assign it to a computer, bad things happen. Just like when you take a computer task that can be repeated over and over and over again, and you give it to a human, bad things happen. You know, there's data entry errors and so on and so forth. Just this fatigue that comes with doing the same thing over and over again. It's boring. They get unhappy. So we don't want to mix up computer tasks that are good for a computer and assign them to people and vice versa. And unfortunately, the EffectiveMunit test recorder kind of does that. It can do some of the heavy lifting for us, but we really need to be thoughtful when we use it because the EffectiveMunit test recorder can create a lot of noise. So that test. Just full disclosure, I'm not going to try to run the EffectiveMunit test recorder in this presentation. Given that this is not even running, I've had issues with the test recorder in the past, just running, and when I'm doing it just by myself here. So I'm not gonna give it a go trying to run it, but I am gonna show you what can happen. Yeah, I'll get into recommended use for the test recorder. Absolutely. Um, but I'm going to show you what happens if you kind of blindly use it. And so what I did here is I ran the test recorder on this particular flow. I went ahead and called it, and I got the inputs and the outputs and everything saved. I didn't really go through anything. I said, okay, well, yeah, I need to mock these two payloads, so let's make sure they're mocked, and 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 uh, and I'll just leave everything else at the default and see what happens. And this is what happened. I think it's this one right here. Nope, it is this one right here. Let's look at this test. Mock getting the social activity. Fantastic. I definitely needed that mock. Not great that it's mocking on the doc ID. I look at the doc ID, and what does that tell you as a developer, right? Oh, cool. You're like great. You're you know that you're probably mocking one single component, right? Like great, but what component is it? Like that's what I need to know as a developer. And it's great that it has this doc name here that says mock get social activity. It's definitely better than nothing. But I would assert that you shouldn't just mock on doc ID alone. You should be mocking on doc ID as well as doc name. And the reason you should mock on doc name is because when you mock on doc name, it forces you to make a good doc name. Keep that in mind. I set the input here. This is a, I'll be honest, I feel like this is kind of a disaster when it comes to, if you're not careful. So none of these values are important, right? I don't need a payload. I don't need attributes, and I don't need variables. Well, there's no variables there anyway. But I certainly don't need attributes. And it does end up setting these attributes that came in. This is what I was referring to earlier with noise. I don't need any kind of headers to make this thing work. But in the input, I'm saying, yeah, go ahead and set these headers. So what is this set event attributes? Do I need any of these for my test to run successfully? No, I don't. If I took it out, my test would run successfully. In fact, my test would be better because it just doesn't have the noise in it. So that's a big problem. Your inputs typically have a lot of noise. And the other problem is the output is not exactly clear in terms of assertions. Like I'm almost always required to go into another file anyway. But I do find personally, and this is someone who's pretty well versed with data weave, that this is just kind of confusing, unfortunately. But I go in here, assert expression payload. Oh, okay, it must equal to this. And now you see the other problem, right? There's nothing here that asserts that my output is XML. And you might argue that that's good. You might argue that it's bad. I argue that if I can't see actually what the output is supposed to be and maybe send it to another team and be like, yeah, this is what the output is going to look like, go ahead and you can start your testing based off of this, then I'm kind of in a weaker position. And then finally, something I already see here in the chat is look at these file names, assert expression payload, mock, and compare them to these file names. Get educational activity response, get social activity response payload. I mean, which one would you rather be working with? These ones that are just extremely vague and kind of generic. Some of them are needed, some of them are not. Or would you rather be working with this where everything is organized correctly? You have to put more effort into this, certainly, you do. But what I'm arguing is that effort almost always pays off. The other thing is it kind of clutters up source test resources. I mean, you can have, so let's say you have 5 EffectiveMunit test suites and each one of those has 10 tests in it. Now you have 50 folders in source test resources, kind of hiding your log4j and anything else you have in there. They really should all go into something called test fixtures or something similar and be organized by test suite and then test name. It just makes it easier to find. It lines up better with the actual organization of your EffectiveMunits, so on and so forth. So when is the recommended, what's the recommended way to use test recorder? When would you use it? Oh, I'm sorry, I missed one thing. The other thing that test recorder doesn't allow you to do, which is important is when you're selecting components and you're saying, oh, I want to mock that, or I want to put a spy there. It's a radio box, which means, or radio buttons, which means you can only select one. You can't mock a payload. You can't mock a component and set a spy on it. So you kind of have to do a little extra work there. Maybe not the worst thing. So, Guru, what I would say is use the test recorder to kind of create the maybe initial files, but make sure you're unchecking things that you don't need. So like, I don't care about the input payload. I don't care about input attributes. So I'd uncheck those two things. When I'm asserting everything at the end, I would make sure I'm asserting only the payload because that's the only thing that I care about. And I just mock these two values. But that still kind of puts a lot of work on me if I want to go in and make sure my tests are readable and well organized. I'm probably going to go through here, move all of these files around, right? I'm going to rename. I won't have as many files. I might have 3 instead of 4. And then I'm kind of good. And then I can just rename them. But then I still have to go back in here. I have to make sure these are pointed to the same thing. Personally, I just find it's more trouble than it's worth. So I don't use it. I don't advocate for it. It's a nice piece of software. I just feel like it's a computer trying to do a human job, and they're just not well suited for that. So what's my thoughts on recording for error scenarios? I actually don't have an opinion. I've never used it for that. So this is kind of the good and the bad about using the test recorder. You can quickly create test cases, and it's probably great code coverage if you record every single flow. The likelihood that you're not going to get somewhere near 70 to 80% is pretty low. But the bad, unfortunately, in my opinion, it outweighs the good quite a bit. It's much easier to create noise, which is going to slow down your team long term. You can forget to mock unnecessary attributes, or not to mock them, excuse me. And you're mocking payloads with hundreds of records, right? Imagine that the response you get back is like some kind of paged response, right? And the first one, you get 100 pages. Well, now you have a test. Now you have a now you have a file in your source test resources that's like, I don't know, like 1 or 2 megabytes in size. It actually wouldn't be that big, but it's large. And realistically, you only need, it might be hundreds of records, but you really only need to assert something about one of them. So you need to go in there and trim up that record. It's just kind of a pain. Poor file naming for things like mock payloads. Poor file naming for everything, actually, except for the actual container that contains all of the files, which is the name of the test. It's just bad. You can't mock and spy on the same component. Really not a big deal, to be honest with you. It's you just go in and create the spy afterwards. Or maybe you want to create the mock because it takes less time to make manually. Mock data is always an application data we format. Not the biggest deal, but again, I really like to have the raw data formats. It communicates more. It says, hey, I'm expecting this to be JSON. I'm expecting this to be XML. It also enables other developers to just copy paste that stuff into Postman and run with it. And file generation clutters source test resources. So fifth, and this is the final major point. I go over some minor points after this as well. But you want to have the value, you want to, in terms of priority, put your valuable test first and your code coverage second. Then it kind of alluded to this earlier in the chat. Code coverage can be a misleading metric for software quality. Very plainly, if your tests are not effective, if your tests are not valuable, if they're not testing anything important, your code coverage doesn't mean anything at all. You could have 100% code coverage, absolute garbage tests, and your manager will be happy, right? Because it looks good, the code coverage is good, you have all these tests, great. But your developers won't be, because they're going to try to work with those tests, and they're just going to be lost, unfortunately. And your team is going to slow down considerably when you need to maintain or add new features, so on and so forth. So write your high value test first. Check if code coverage criteria is met. If it's not met, add more if necessary. Add more tests if you need to if you necessarily need to. Um, I don't think I expressed what I feel like a high value test is, and let me just go back to the code real quick. To me, a high value test is any test that's just testing the important interfaces of your application. This is an important interface. What goes into this? I need to test that. What is coming out of this is an important interface. What goes into this is an important interface. Let's say if I had a let's say I had a flow reference to this flow instead of some kind of listener instead, and this is just part of my overall larger flow. I would probably want to put a spy on that flow reference and assert that the variables that are going into that flow reference and the payload that's going into that flow reference, if the payload is needed, are the correct values. And then when I'm actually testing the subflow itself, I would assert something like I would just assert that given certain outputs that the inputs are correct. But I do need to make sure that this parent flow that's calling that child flow is passing that child flow the correct information given the inputs to the main flow. So to me, high value tests, make sure you're testing your important interfaces. That's inputs to flows, that's outputs from flows, that's inputs to calls to dependent systems, that's databases, that's downstream APIs, etc. And make sure, especially if you have request and response that are a synchronous API like REST, that given the input data that you gave it, that what is coming out of the flow is correct as well. Just wanted to clear that up. I don't think I was very clear about that. Your code review should be exposing weak tests. We, at the client that I'm at now, we've built enough tooling that we've really reduced the mental burden of looking at tests. We don't look at things like, hey, are all of your variables the same case, and are all your data weave files in the right folder and things like that. We have tools that do that stuff for us. Your team should be creating tools that do that work for you, because they just create this mental burden, this cognitive load that you don't need to succumb yourself to every single time. If it can be automated, go ahead and automate it. So we don't spend any time doing that kind of stuff anymore. Our code reviews are all now, hey, this flow seems a little weird. Why did you do things this way? Or, hey, you're checking that the size of this variable is 0. Why don't you just check if it's empty instead? This data weave code could be more efficient or more easy to read. And then finally, like the stuff that's really important here that we're talking about, unit tests. Hey, you have this unit test. You're asserting this. There's like a million values it could possibly be with that assertion. Can you narrow it down given your inputs? So this helps mitigate developers aiming for code coverage instead of high value tests. So make sure when you're doing code reviews that you're really diligent about checking out the tests. In my experience, developers get the functionality right. You give them a set of requirements, their code is going to meet the requirements for the most part. And if not, they'll find stuff when they throw it into dev and throw it into test that they can go back and fix. But tests, not so much. Tests kind of can fly under the radar and quietly cause damage to your team's productivity. So you really need to be diligent about checking those out. I would say I spend the large majority of my time in a code review making sure that the unit tests are correct, and less so time making sure that the implementation is actually correct. And part of that just comes from trusting your team as well. If code coverage is 100%, this is a question in the chat, I think. If code coverage is 100%, but if the tests aren't valuable, example of such a use case. Oh yeah, absolutely. Here, I'll just show you a concrete one right now. This is my bad test. This is my good test. So Aman, in this case, this is just my regular, the flow that I'm testing here, right? And given that I get certain values back from these, I should get good I should get this value as XML, right? After the transformation. I need that specific value. So a bad test that would give me coverage for that entire flow, for example, would me just coming in here and being like, let's see, okay, go to EffectiveMunit. Where are my asserts? That's weird. Oh, it's EffectiveMunit tools. Okay. Yeah. Definitely want to assert that. Okay. I want to assert that it's not a null value. Man, this is let me do that. I delete this. Now, Aman, I have a test here that is going to pass almost every time, no matter what. I have full code coverage. I'm calling this. I'm calling all of these processors. Let's assume this test isn't here, right? I have 100% code coverage, but I could go in and delete that, and my test would pass. 100% code coverage, but my tests are weak. They don't assert anything useful. That's an example. Thanks for asking. All right. Okay, we got it. We're going to go through the other tips, and then we got trivia afterwards, and then we're wrapped up. So other tips, unit tests, I kind of alluded to this earlier, unit tests should not be dependent on the use of the network or file system. Let me clarify this a little bit. This doesn't mean that your EffectiveMunit test should never like test your API contract, right? So you start up the application and you are actually sending HTTP requests and mocking things to make sure that nothing too crazy happens on the other side. Those tests are fine. They're not really unit tests. I'd argue that they are a form of integration tests, maybe. Point being, they should be isolated from your actual unit tests that do not involve the network or the file system, so that you have a means to run them individually. Like, so for example, I might not run my integration tests during a build process to dev. So I just run my unit tests. I need some way to say, just run my unit tests, don't run my integration tests. I know they're all EffectiveMunit tests, but you need to have a way to do that. And the only way you can do that is to segregate them into separate files. And then when I move to test, I might say, okay, well, I actually do want to run my integration tests here in this case. So if they're actual unit tests, they shouldn't be dependent on the network or the file system. You can write integration tests in EffectiveMunit, and I don't think that's like bad style or anything like that. What is bad style is when you mix in your integration tests with your unit tests and act like they're the same thing, because they're not. They have different use cases, and they offer different things to teams. If you have code that's more complex, you're probably well off having more robust tests. The most complex logic in your application might have tests that are like 5 times as long as the source code that needs to implement it. And that's okay. But the inverse is also true. If you have really simple code, like don't waste your time testing a ton of different scenarios on it, because you're just not going to get that kind of payback. There's always this balance between writing the unit test, which costs time. It costs developer resources. Like really, it costs really valuable resources to write these unit tests. You have to make sure that the value that you're getting out of them is bigger than the time and the effort that you're putting into them. So tests should function as a form of documentation. So expected inputs to flows and dependent systems, as well as expected outputs. It's a great form of documentation for other developers. Nobody else should really be concerned about your unit tests except for your manager if they care about things like code coverage. But the tests are there for you as a developer. The tests are there for your other developers as well. That's who you're writing them for. So make sure that, kind of think to yourself, man, if I was, if I came back to this application 3 months from now, could I look at the unit test and kind of understand why I made the decisions that I did, and at least some of them, not all of them, but can I understand what values this flow needs as inputs in order to work correctly without actually digging into the source code itself. I should be able to look at the test and just easily figure that information out. You want to test all paths. Generally, flows with choice routers require one test per possible path. This includes exceptions as well. I don't have time to go into it with this presentation, but testing exceptions is a little more complicated just because of EffectiveMunit doesn't let you mock the error object. So you need to find ways to work around that. Real briefly, the way I work around it is I just set everything in a variable. In the exception case, like I'll set error into whatever I need to do. That way I can mock it, right? I can finally mock the error object, and then I pass everything off into a flow ref. Testing data weave code. I used to be a big proponent of testing data weave code directly. And the more I started writing unit tests and the more I saw like what unit tests I needed to change in what scenarios and so on and so forth, the less I started testing my data weave directly. It is one of the most complicated parts of your application many times, but you have to consider that it's just an implementation detail, right? When I'm calling your flow, I shouldn't care if you're using data weave or not. You could use Java, you could use Groovy, you could use Python. It just shouldn't matter. So if you keep your tests at the interface of the input and outputs of the flows, the inputs and outputs of HTTP requesters, data weave just becomes an implementation detail, and you can really clean up your M units and keep them more simple and keep the value high if you kind of ignore the fact that data weave is there and just assume it could be anything else. Never mock on doc ID alone. Always include at least the doc name, because I'm gonna look at the code. I'm going to go into the mock and try to see what you're mocking, and I'm just going to get the doc ID. And yeah, I could use like grep and go through the file or use find and try to find it, but like, why would you want to do that to somebody? Like, it just spends a lot of their time that could be used thinking about important things instead. And the last one, never trust a test if you haven't seen it fail. If you wrote the test, I generally trust tests that other developers have written if I look at them and they look solid. But if I've written a test myself and I've never seen it fail, I'm highly skeptical. So I typically, when I write my test, I go through this flow. I'll write the test. Sometimes I write the test beforehand. More often than not, I write the test after I write the implementation. And it passes. Okay, great. Now I go into my implementation. I'm like, okay, well, what are the critical parts of this flow that need to actually happen? And then I either mess them up or I delete them, and I run my test again. If my test doesn't fail, my test is useless, right? It needs to fail in those scenarios. And once you've seen it fail, you're like, oh, okay, well, this will work. If another developer comes in here and maybe accidentally presses backspace when they are on this processor and doesn't realize it and they go on to something else, my test will actually catch that and let them know. So that's really important. All right, last trivia question. When writing unit tests, why should you focus on writing valuable tests first and code coverage second? A, without valuable tests, code coverage is meaningless. B, code coverage isn't that important. C, valuable tests are difficult to write, so we should approach them with a fresh mind. Or D, an authority figure said so in an online presentation. All right, yeah, the answer is A in this case. Without valuable tests, code coverage is meaningless. I talked about this earlier. If you can break your tests, if you can't break your test by just deleting random stuff in your code, and you have 100% code coverage, that it doesn't really mean anything. It just means you have bad tests, unfortunately. So I think that was. Nice job. I wanted to go back and, cause my last section is if anybody has any questions here. So I want to go back real quick and because there's a couple questions. The book details have been shared. Um, yep, this is all recorded. The DW tutorial. Oh wait, no, this one. Do you use social unit tests? I'm going to answer the other question while I ask this. What do you mean by social unit tests? Let me know in the chat, and I will. I'll scroll down. In the meantime, can you please share the data weave tutorial? The data weave tutorial is. Oh man. I want to do that. The data weave tutorial is just. It's on the data weave playground. This is it. So this is what I wrote. In my opinion, this is one of the best introductions to data weave that there is out there, simply because you get this wonderful interactive prompt, so you can kind of go through here and actually try doing the data weave stuff instead of just reading the documentation and kind of going from there and doing it separately. So I find this really nice. It's also a good, I think it's a good like flow into learning it. You know, we just talk about what data weave is, what is data, how do we read data, our query data variables, and it's just a good flow into like more and more advanced topics until you finally get to functions and so on and so forth. Oh, social tests, integration tests. Okay. So the question was, do you use social unit tests? Social being, social doesn't mock external dependencies, and it basically serves as an integration test. Do I use them? No, not personally, I don't. That's not to say they're not useful. I just, in terms of like time value for like what I'm putting into it, you don't either. Okay. I just find it's the real value is in the unit tests. And if you have end-to-end tests and other things that you can automate, that's great. It does take a lot more knowledge about those tests and why you need certain tests in certain scenarios. Testing is a really deep topic, and you can go. There's different kinds of tests. There's end-to-end. There's integration. There's also unit tests, and they all apply to different scenarios. So the only one this presentation went over is unit tests. That's the one I typically always advocate for. If you're only going to do one of the three kinds of tests between unit, integration, and end-to-end, you want to do unit tests. That's not to say that you shouldn't do the other ones. They're equally important. But that's just kind of my opinion. I'm sure other people have other opinions and feel like end-to-end tests are probably the way to go, and so on and so forth. And I think that that wraps us up. Does anybody have any other questions related to EffectiveMunit, MuleSoft, DataWeave, anything? If not, you can always reach out to me on LinkedIn. I usually put my contact information here in the presentation, but I'll just I'll add my profile here. LinkedIn is definitely the best way to get in touch with me. I do have a Facebook page and stuff, but I don't really monitor it all that much. So yeah, if you want to get in touch, if you have any questions about unit testing or software development in general, this is a great place to reach me. And so there. All right, thank you. Ikram, I'm gonna pass it back to you.
Thanks, Josh, so much. And thanks everyone for joining today's meetup, and hope you have learned something new. I learned different perspective from Josh on EffectiveMunit, so I'll try to in my projects possible. And please share your feedbacks, either positive or negative, so that we can improve ourselves. And it's a good learning for us as well to know your feedbacks. And that's it from me. Thanks for everyone, and thanks and congrats. Thanks so much. I'll stay in
Yep,
touch. Thank you.
absolutely. Have a good weekend, everyone.
Thank you.